Hey everyone, if you're building anything for the web, you need to know that you're on the front lines of a constant battle for security. So today, we're going to break down an essential guide for any student or aspiring developer. We're diving into the three most common and frankly most dangerous vulnerabilities you're going to face: SQL injection, cross-site scripting, and cross-site request forgery.
So here's our game plan. First, we'll get a high-level look at this vulnerable trio. Then, we're going to do a deep dive into each one: SQL injection, cross-site scripting, and that tricky one, cross-site request forgery. We'll see how they work and, more importantly, how you can stop them. And then, we'll wrap it all up with a side-by-side comparison to make sure these concepts really stick with you.
All right, let's start with the big picture. Think of these three vulnerabilities as a crew of specialists. Each one has its own unique target, its own special way of breaking into a different part of your application. Understanding what each one does is absolutely the first step to building a solid defense.
And this slide right here lays it all out. SQL injection, or SQI, goes right for the crown jewels, your database. Cross-site scripting, or XSS, is different. It actually turns the user's own browser against them. And then you've got cross-site request forgery, or CSRF, which is all about exploiting the trust between a user and your website. Since they all attack different layers, you can't just have one magic bullet to fix them all. You need specific strategies for each one.
Okay, first up in our deep dive is SQL injection. This is the one that's aimed squarely at the heart of your application. It's data.
So here's the core of the problem. SQL injection happens when your application blindly trusts whatever a user types into a form field. If you don't clean up or sanitize that input, an attacker can sneak their own database commands right in there, and your application will just run them. It thinks the commands are legit.
It's a really simple but devastating three-step process. First, your code starts building a database query using input from, say, a login form. Step 2, the attacker crafts some special input designed to totally change the meaning of your query. And finally, Step 3, your database, just doing what it was told, executes the attacker's malicious command instead of your own.
Now check this out. This example is where it really clicks. Look at that tiny bit of input, or 1 equals 1 dashes. It seems like nothing, right? Wrong. The first single quote cleverly closes the username field. Then, or 1 equals 1 is a condition that is always true. And the last part, the double dashes, that's a comment in SQL. It tells the database to just ignore everything that comes after it, including the password check. And just like that, the query basically becomes find a user where 1 equals 1, and the attacker gets in.
And once they're in, the damage can be catastrophic. We just saw them bypass a login, but they could also read sensitive data. We're talking user info, credit cards, you name it. They could modify it, or worse, delete entire tables or even the whole database. This is exactly why SQLI is one of the most feared vulnerabilities out there.
So how do we stop this? What's in our developer toolkit? Well, the number one absolute golden rule is to use prepared statements. This is a technique where you send the SQL command to the database first, and then you send the user's data separately. Because they're separate, the database never gets confused and mistakes user input for a command. Using tools called ORMs, validating input, and limiting database permissions are all other critical layers of defense.
All right, let's switch gears. We've been talking about the back end, the database. Now let's shift our focus to the front end, to the client. Our next vulnerability, cross-site scripting, or XSS, targets the user's browser, hijacking the trust it has in your website.
With XSS, the attacker's whole goal is to get their malicious JavaScript onto your web page. When an unsuspecting user visits that page, their browser sees the script, thinks it came from a trusted source, and just runs it. No questions asked.
Now, XSS comes in a few different flavors. Stored XSS is probably the most dangerous. That's when the bad script gets saved permanently on your server, like in a user comment. It's like a landmine waiting for every user who views it. Then there's reflected XSS, which is when a script is part of a malicious link that gets reflected back from your server to the victim. And finally, DOM-based XSS is a really sneaky one that happens entirely in the browser itself.
And look at how simple a stored XSS attack can be. An attacker just leaves a comment, but instead of writing text, they pop in a little script tag. If you don't handle this input correctly, your website is going to serve that script up to every single person who views the comments page, potentially running a function like steal cookie.
So what's the big deal if they steal a cookie? Well, that session cookie is basically the key to the user's account. With it, an attacker can hijack their session and impersonate them completely.
They can change what the user sees on the page or even send them to a phishing site to steal their password. The attacker effectively takes total control of the user's experience on your site. So preventing XSS is all about treating any content from users with suspicion. Your main defense is to always escape your output. That just means you convert special characters, like the less than and greater than signs in a script tag, into a safe format so the browser treats them as text to be displayed, not code to be executed. A strong content security policy, or CSP, is another powerful layer of defense that tells the browser exactly which scripts are okay to run.
And now for the final member of our triad, cross-site request forgery, or CSRF. Now this one's a little different, a bit of a mind-bender. It isn't about injecting code or stealing data directly. Instead, it's about tricking a logged-in user into unknowingly doing something they never intended to do.
The best way to think about it is like this. Imagine a scammer forges your signature on a check. Your bank sees what looks like your signature and cashes the check, having no idea you weren't the one who actually signed it. CSRF works exactly the same way, by exploiting the trust a website has in a user who's already logged in.
So here's how the con plays out. You're logged into your bank's website. Then, in another tab, you visit some other malicious website. That site has a hidden request on it, maybe to transfer money from your bank account. And here's the kicker. Your browser, trying to be helpful, automatically attaches your banking session cookie to that request. Your bank sees a valid request with a valid cookie, and boom, it processes it. The way they do this is often with a hidden form on the attacker's page that submits itself the second the page loads. The user sees nothing, they click on nothing, but in the background, their browser has just been tricked into sending a command, like changing their email or password on another site, all on their behalf. It's totally invisible.
And this is why CSRF is so scary. An attacker can do literally anything the logged-in user is allowed to do. They can transfer funds, change your password, post messages as you, delete your data, you name it. And your application has no idea that the request was forged. The classic defense here is something called an anti-CSRF token. Think of it as a unique secret password that's only good for one request. Your application gives one to the user's browser, then for any sensitive action, the browser has to send that secret token back. An attacker's website can forge the request, but it has no way of knowing what that secret token is, so the forged request gets rejected. It's a fantastic defense.
Okay, wow, we have covered a lot of ground. We've taken SQL, XSS, and CSRF apart piece by piece. Now, let's put them all side by side to really hammer home the differences and help you remember how to spot each one.
This table sums it all up beautifully. Let's just go down the line. First, the attack target. SQLI goes for the database, XSS goes for the browser, and CSRF goes for the user's session. Okay, what about user interaction? SQLI often needs none. XSS sometimes needs a user to click a link, but CSRF almost always requires tricking a user into visiting a malicious page. And finally, the main weakness they exploit. SQLI abuses your trust in user input, XSS abuses your trust in content, and CSRF abuses the browser's habit of automatically sending cookies. So, we've laid out the attacks, and we've laid out the defenses. We've seen how they target different parts of your application by exploiting different kinds of trust. So the real question to leave you with is this. Looking at your own code, at your own projects, which of these prevention techniques are you going to implement first? Because thinking about security from the start, well, that's what separates a good developer from a great one. Thanks for tuning in.